Good morning, students. I am Dr. Neha Sharma. In a previous class, we have started a topic, motion, that is the eighth chapter of your book. We just defined the term motion, that is any object, if changes its position with respect to time and with respect to frame of reference, then that object is known as a, then object is defined as it is in a motion. We define the basics of the motion, and also along with that we define the different types of the motion, that is rectilinear motion, circular motion, rolling motion, periodic motion. So for on moving further, in today's lecture we today discuss about that motion in a straight line, that is a rectilinear motion, and define some physical quantities like distance, displacement, and some other terms. So before moving further, I would like to discuss about the physical quantities. As I already defined that the topic motion is related to the subject physics. So in physics, every parameter or every quantity is defined is as a physical quantity. Physical quantities are those quantities that can be measured, just like length, mass, time, temperature, work, force, pressure. Each quantity are defined as a physical quantities because they can be measured. They have some value, right? If I'm saying that about light, light is not a physical quantity, right? Because it cannot be measured directly. But the intensity of light or the wavelength of light are defined as a physical quantities because we can measure them. Similarly, sound is not a physical quantity because sound cannot be measured. But the intensity, its wavelength, frequency, sound velocity, the time period, these parameters are considered as a physical quantity in that case. I hope it is clear that every quantity which can be measured are defined as a physical quantity. So physical quantity can be divided or classified into two types, right? First one is the scalar quantity and second one is the vector quantity. Scalar quantities are those type of quantities that depend upon magnitude but not on the direction, right? And vector quantities are those quantities that depend upon the magnitude as well as on the direction. Now you are thinking about that what is magnitude. So first I would like to define magnitude is related to the value or amount. If any quantity has its value or amount, just like length, if I'm talking about length, suppose I'm having a pen. Suppose this pen, length of this pen is approximately 12 centimeter, right? So the magnitude is the 12 centimeter, that is the magnitude or length of this pen. This value can be measured easily. That's why we define it as a physical quantity, right? But it is not depend on the direction. If I put this pen in a horizontal type or in a vertical type or in a slant mode or any of the direction, the length of this pen is not changes, right? So this type of quantities which don't depend on the direction but it has some value is defined as a scalar quantity. Like temperature, if I'm saying the temperature of this room is approximately 32 degrees centigrade, right? So the temperature is through in all the room is same. It don't depend on the direction. That on the horizontal part on a floor the temperature is different. At the roof part the temperature is different. That can't be possible, right? Like on some other part that your height, suppose your height is approximately 5 feet 5 inches. If you're lying on a bed, the height is same. Still, if you are suppose standing on a floor, the height is still same. It doesn't depend that you are basically in a horizontal part or you are in a standing position. This quantity is not changes along the direction. So these type of quantities which has some value, which has some magnitude, but don't depend on the direction is defined as a scalar quantity. I hope it is clear. Now second type of quantity that depend upon magnitude, means it has some value, as well as it also depends on the direction, are called vector quantities. Just like force, how can we define it as? Suppose I have a piece of sponge, right? I'm applying some force at the surface. Suppose the force is approximately 10 Newton. Newton is the basically the SI unit of the force. If I'm saying that I'm applying a 10 Newton force at the tip of this surface, so the direction matters, because at which surface we are applying a force, that surface faces that force, and that can be deformed if the force is excessive. Suppose I am applying a force into this direction. The portion is pressed, right? If applying a force into a right direction, means it has some value. The value is approximately suppose 10 Newton, and it is applying into the direction in a right side. So it has a depend on the direction also, because this surface can only deform because the force is applying on this direction only, right? So this type of quantity is defined as a vector quantity, where the value or quantity has some value or magnitude, and it also depends upon the direction of that quantity, right? So these are the some basic terminology. In this chapter or in your syllabus, there are the number of physical quantities like distance, displacement, speed, velocity, acceleration. We will discuss all these quantities one by one in our next slides, right? So before starting that, now the topic is the motion in a straight line. In the last class, I have discussed that the motion in a straight line is defined as a rectilinear motion or one-dimensional motion. As there is an in a left side corner, I defined some coordinates, because in physics, if we want to locate an object in a coordinate axis, that some object is resides in a x direction or maybe in a y direction, maybe means I want to say that some coordinate we have defined that in which state or in which coordinate that particular object is lying, right? So when I'm talking about a rectilinear motion and motion in a straight line, that type of motion or movement is the one dimensional only. Like in a previous class, we have discussed that maybe any object in a horizontal or maybe in a vertical. Like I'm giving an example of that car is moving on a highway. If there is no obstacle, no traffic, no turns, it is moving in a straight line, then that type of motion is defined as a rectilinear motion or motion in a straight line. That time the direction is a horizontal path, right? Axis. I'm also giving one more example that if you've now thrown some stone from the top floor of any building, then that type of movement is a vertical movement. So the movement is in a straight line. So that type of motion is also defined as a rectilinear motion. One more example, suppose aeroplane is taking off. So it take in a slant mode and taken some height. So this slant motion is also a linear movement because it's now follows some straight line. So the rectilinear motion or motion in straight line can be in a horizontal direction or maybe in a vertical direction or maybe a slant direction. If it follows a straight line or single line, then it is defined as a rectilinear type of motion. Now we further discuss into this is the number line calculation. I'm giving you one structure that there is a one turtle who is moving from 0 to 8 meter. The distance, total distance he traveled is defined in a meter. Suppose initially it is at 0 point. As in my previous class, I already defined that for judging an object that it is in motion or not, we need any reference point, a frame of reference, or some origin point, right? It is a very important parameter. And normally this parameter is a stationary point. Suppose I'm talking about a turtle. It starts from 0 meter. Suppose 0 is the origin point or initial point or the starting point from where it started traveling, right? Initially, it moves up to a 3 meter, means the distance traveled by that turtle is 3 meter. Now, it stops at 3 meter. Again, he decided to move up to 8 meter. Now, in first case, the reference point or the origin point is 0 meter. In the next stage, where he decided to reach up to 8 meter, the reference point or the starting point is the 3 meter. When it moves up to 8, so the distance traveled by the turtle is 5 meter, because the starting point we already always consider that motion from the reference point or the origin point or the frame of reference. So the starting point is 3 meter and it is reaches up to 8 meters. So the distance traveled by the turtle is approximately 5 meters. So basically this calculation can be used to identify two more important physical quantities, that is distance and displacement. We discuss in detail these two terms. So distance is the total path covered by body in any direction is called distance. How can we define this term in a simple way? Suppose your school is approximately 5 kilometers away from your home. You start moving from your home to school. You cover the distance approximately 5 kilometers. Then, on returning from school to home, you again cover a distance of 5 kilometers. Sorry. So the total distance traveled by you is that 5 plus 5 is 10 kilometers. So distance is defined as the total path covered in any direction. If I'm saying that some more example like railway station is approximately 2 kilometers from my house. So the 2 kilometer is the magnitude. It is the specific quantity which I defined, that it is the distance that is approximately from the two-wheeler. We cannot define it as that first we move north and then we move in the east direction, then we moving into the west direction. We are not defining into like that. We are not defining the direction at all. So this the basically the path traveled between two different positions is defined as a distance, right? That is the total path covered or total path traveled. Now the second parameter, as it is a scalar quantity, as it is has some value but don't depend on the basically the direction. So we define distance as a scalar quantity. Now the second important physical quantity is the displacement. So displacement is defined as the change in position of an object. Basically, in a simpler term, we define distance as the shortest and straight line distance between the initial and final point of the object is called displacement. Now, how can we define it? We discuss with an example. Suppose a girl started moving from point A and he reaches a point B. The distance covered by her is 15 meter, right? So distance tells us about the path traveled by anybody, right? Or any person. Means how much total path he covered. And now what is distance displacement? Displacement basically depend on the initial and final position, right? It tells us that how far the body is from its initial position and in which direction. It actually related with the direction. Like I'm saying that when he travels from point A to point B, it is cover 15 meter in the east direction. So the displacement is 15 meter. Now you may be confused with these two terms because the value of distance and displacement both are same. Both are having a same unit, a meter, because we are talking about some distance. Now we further discuss it. Suppose this girl again started to return back from point B to point C and he stops at point C after covering a distance of 5 meters. Now, what is the total distance? As I'm defining, the distance is the total distance covered by any body, right? So, total distance can be defined as the distance between point AB and distance plus point distance between B and C. So, means the total distance covered is 15 meter plus 5 meter, that is 20 meters. So the girl basically covered a 20-meter distance, right? Now what is displacement in this case? The final position is point C, right? And initial position is point A. I mean defining the displacement is the difference between these two positions, that is final position minus initial position, right? Final position is, that is minus 5, is approximately 10 meter. So basically it is 10 meter away from her initial position. So that is the displacement, right? But displacement also discuss about the direction, that in which direction it is displaced. So we can say that the displacement is 10 meter in the east direction. I hope I am clear with these two examples. The distance can never be zero, right? But the displacement always may be zero or maybe positive or maybe negative. How? As I'm saying that just I giving example that you started a journey, you go to your school and coming back to your school. What is the displacement in that case? The distance that is traveled by you is approximately 10 kilometers in that example. But the displacement is zero because you started from your home and you reaches again back to your home. You are not staying at any other place. So the displacement is zero in that case. I hope I am clear. So we can discuss this by one more example. I'm showing one picture over here that that is related to one famous cartoon, that is Tom and Jerry, right? So I like to discuss this example into very detail, that both distance and displacement are the physical quantities, right? And both represents the length of the path traveled by any object from one position to the another. Okay. So now in this example, Jerry wants to reach its goal before Tom grabs him, right? So he decided to go towards the hole from the path, which is A to B and B to C, that is 4 meter plus 3 meter long. Means the length of the path traveled, we defined that it is called distance. So the total distance traveled by Jerry is approximately 7 meters long, right? So in this way, we can say that Jerry traveled a 7-meter distance. Now let us talk about the Tom. What he did to catch Jerry on time. Instead of following Jerry, he took the path which is 5 meter long from the hole. And this path is a straight line distance from Jerry's home. Now this straight line is the shortest distance between the 2 points A and C. And that's how Tom caught Jerry. So the shortest distance between any 2 points is known as a displacement. I hope I am clear with this point, right? So displacement is the shortest distance and it is represent with a straight line only. It cannot define it as in a curvy nature or some other path. Distance can be differ. Suppose I like to move, I like to go back to my home by taking different routes. So distance can be different, right? For both the position, for initial point and a final point. But the displacement is always same. It is the same quantity. So displacement is basically can in mathematically can calculate as final position minus initial position. The value of distance is always greater than or equal to the displacement. As I'm giving an example of that girl who is following some path. In the first case, the distance and displacement is the same. In the second case, the distance is larger, whereas displacement is very less in that case. So we can say conclude that distance can be greater than or equal to the displacement part. So displacement, we further discuss about this term more, that displacement is the straight line joining the initial and final point. Like I'm giving a showing one picture where two home is there, point A and point D. Suppose you want to point A is your own home and you want point D is your grandmother's home. You want to reach your grandmother's home. You follow different paths. One path is 10 kilometer long, second path is 7 kilometer long, third path is 5 kilometer long. Now it's your choice that which path basically you have chosen to reach your grandmother's home. Now your friend suggests there is a shortest path in a east direction from your home to your grandmother's home that is 2 kilometer away, right? So in that case, the displacement between, we can say the distance between the final position and initial position is fixed. So that point, this 2 kilometer is defined as a displacement. Whereas because it always represent as a straight line and it is some constant value, it never change. Whereas distance always changes. So the basic difference is that as defined that distance is a scalar quantity. It has some values, but it don't depend on the direction. Displacement is a vector quantity. It also depends on the direction. We have to mention that in which direction the particular object is displaced, right? Displacement has a constant value. It is never changes. It basically difference between the initial and final position. Whereas distances don't have some constant value. The path may be different. So the distance traveled between two objects can be differ. I hope the difference between distance and displacement is clear to you all. Now what about if the path covered by a girl is a circle? In that case, the distance is the circumference of the circle, that is 2 pi r. R is the radius of the circle. Okay. Now what is the displacement? If a girl is started from point A, it traveling along with the circumference of the circle, it again reaches to the point A. So the displacement is zero in that case. So this is some other examples that by which we can easily define these two quantity, the distance and the displacement. Now another parameter is in this chapter is the uniform and non-uniform type of motion. As a term defined, uniform motion is a type of motion in which object covers equal distance in equal interval of time. Then what does it mean? We understand this term by two examples. Suppose I'm giving an example of a car moving in a highway. There is no traffic, there is no obstacle, no disturbances when car is moving. So normally the distance covered by the car is normally equal with respect to the time. Like after 1 kilometer, maybe it covers 10 kilometer. After 1 hour, maybe it covers 10 kilometer. After 2 hours, maybe it covers 20 kilometer. So this type of movement where equal distance is covered with respect to equal interval of time is defined as a uniform motion. Other example is there is one picture that shows that Earth is revolving around the Sun along with their orbit, right, or their axis. This is again a uniform type of motion or uniform motion because the distance at particular point is always same along with the equal we can say interval of time. Along with the time period, the distance traveled by the earth is normally equal, right? So there are so many number of examples which defining a uniform motion, that quantities basically with respect to time has same type of path. It has shows, if we plot a graph, it shows a straight line. We further discuss it by some numerical data. As I'm giving an example of a car moving in a highway, when there is no obstacle, there is no traffic at all, or no cars, etc. So the data is that I'm giving one table, time and distance. Time is in hour and distance is in kilometer. Suppose after 1 kilometer, the distance traveled by the car is 10 kilometer. After 2 hours, the distance is 20 kilometer. 3 hours, 30 kilometer. 4 hours, 40 kilometer. 5 hours, 50 kilometer. You can observe that as the time changes, the difference between the time is same. We are taking the same time interval. Similarly, the distance covered by the car is also same. The interval is same. So if we plot a graph, you can see a graph that shows a distance between time and distance. When we plot a graph, we get a straight line type of curve. So in uniform motion, when we plot a curve, so we get a straight line. So this type of motion is defined as a uniform motion. Second type of motion is the non-uniform motion. Non-uniform motion is a motion in which object covers unequal distance in equal interval of time. What does it mean? Suppose a same example. The car is moving on a highway. Now suppose it is not moving on a highway, it is moving in some city and it faces so many obstacles. Maybe somewhere the traffic is very high, somewhere traffic is very less. So in that case, sometimes it reaches very early, it covers so much distance in a particular period of time, and sometimes due to traffic it takes very less time or very covered very less distance with respect to the previous time interval. Like I'm giving a table between time and hour, that after 1 hour the time interval is equal. The distance covered by a car is 2 kilometer. After 2 hours it is 3.5 kilometer. After 3 hours 4 kilometer. After 4 hours 5.5 kilometer. And after 5 hours 6 kilometer. Maybe due to the traffic, sometimes it takes very large time to cover this particular distance, sometimes it takes very less time. So this type of movement or this type of motion is defined as a non-uniform motion. And the curve, you can see that the curve between time and distance, it is not in a straight line. So this type of motion is defined as a non-uniform motion. I hope this lecture is clear to you, that we discuss some parameters, the motion in a straight line, how can we define it as, then further we discuss about the distance, displacement, uniform and non-uniform type of motion. Thank you.